Out in the farthest reaches of our solar system, where the sun is a distant, faint star, there exists a place that, at first glance, seems inhospitable, a world far colder than anything we could ever imagine. A world that is both alien and familiar, a frozen moon drifting silently through the endless expanse of space. This is Enceladus, one of Saturn's many moons. To the untrained eye, it might look like nothing more than a pale speck, blanketed in ice, forever frozen in time. A frozen, lifeless orb. But what if I told you that beneath its icy surface, hidden far below the hard crust, there might be something extraordinary, something that could change our understanding of life itself? This small moon, only about 500 kilometers in diameter, is not just a ball of ice. Enceladus has a secret, and it is one that has captivated the imaginations of scientists, dreamers, and explorers alike. A vast, hidden ocean beneath its frozen exterior, capable of supporting life. Life, that mysterious force, might exist here in ways we've only dreamed of. When you gaze at Enceladus from afar, it's hard to imagine that beneath its frosty surface, something as profound as an ocean could exist. The moon's surface is a patchwork of gleaming, reflective ice. It's a barren landscape, bathed in the pale light of the distant sun, where temperatures plummet to minus 200 degrees Celsius. On Earth, ice means frozen stillness. But here, on Enceladus, that ice is the surface of something much more dynamic. The frozen exterior hides an ocean of liquid water, kept warm by forces far beyond our reach. This is no ordinary moon. It's a world in motion, one whose secrets are only beginning to be uncovered. For years, scientists speculated that Enceladus might harbor a subsurface ocean, but it wasn't until 2005, when NASA's Cassini spacecraft flew by the moon, that this theory was confirmed. Cassini detected the most remarkable thing: geysers, tall plumes of water, ice, and vapor, shooting out from the moon's south pole, bursting into space with the force of a boiling kettle. These geysers were not just a wonder of nature. They were proof that something far more complex lay beneath the surface. What could possibly cause these geysers to shoot into space? The answer, it turns out, lies in the tidal forces at play. Saturn's immense gravity and the interactions between Enceladus and its neighboring moons create powerful forces that flex and stretch the moon's icy shell. This stretching generates heat that prevents the water beneath the surface from freezing solid. Instead, it keeps the subsurface ocean warm enough to remain liquid, even though it's far from the warmth of the sun. This process, known as tidal heating, is the engine that powers this hidden ocean, keeping it in a state that could potentially support life. But this heat isn't just keeping water from freezing. It might also create a chemical soup within the ocean. Just like the hydrothermal vents on the ocean floor of Earth, which support thriving ecosystems, Enceladus Ocean could harbor similar conditions, rich in chemicals, heat, and perhaps even the nutrients needed for life. Imagine, for a moment, an environment that thrives beneath an ice cap, miles and miles of water teeming with life, in the complete darkness of space. No sunlight, no warmth from a nearby star, just the heat from tidal forces and the chemical processes deep within the moon's core. Could life exist in such an environment? Could life emerge here as it did in the deepest parts of our own oceans? Now, let's talk about the key ingredients for life. On Earth, we often take these for granted: water, energy, and organic compounds. But when you begin to imagine life beyond Earth, these ingredients become the focal points of our search. Enceladus has water in abundance. Cassini's instruments detected liquid water in the plumes erupting from its surface, suggesting a vast ocean that stretches deep below. That's step one. Step two is energy. Without energy, life cannot thrive. On Earth, life near hydrothermal vents flourishes because of the heat and chemicals spewed from the Earth's crust. On Enceladus, tidal forces from Saturn are generating heat, and it is likely that the ocean beneath the surface is rich with chemical energy, much like the depths of our oceans. Enceladus Ocean isn't just cold water. It's a dynamic, heated environment that could potentially create the perfect conditions for life to form. Finally, there's the question of organic compounds, the complex molecules that form the foundation of life. Cassini found evidence of these compounds in the geysers erupting from Enceladus, including organic molecules such as methane, hydrocarbons, and amino acids. These organic compounds are the building blocks of life, suggesting that Enceladus Ocean might have the raw materials necessary for life to arise. Water, energy, organic compounds. These are the core ingredients that life requires. Enceladus has all of them. But what about life itself? Could there be actual organisms living in Enceladus Ocean? While the idea of complex life, plants, animals, or intelligent beings, might seem far-fetched, the possibility of microbial life becomes far more plausible. On Earth, life began in our oceans. Organisms that were simple, microscopic, and capable of thriving in dark, extreme environments. Around hydrothermal vents deep in the ocean, life found a way to survive, using chemicals in the Earth's crust as an energy source instead of sunlight. Could something similar be happening on Enceladus? Could tiny, microbial life forms be feeding on the chemicals in the water, growing in a warm, chemically rich environment? These organisms would likely be simple, perhaps resembling extremophiles, life forms that thrive in the harshest conditions. Microbial life on Enceladus would likely be small and simple, but its existence would represent an astonishing breakthrough in our search for life beyond Earth. It would suggest that life doesn't just need Earth-like conditions to exist. Life might exist in far more diverse environments than we ever imagined. Enceladus is not the only moon in our solar system that might harbor life. Scientists have long looked toward Jupiter's moon Europa, which also has a subsurface ocean beneath a thick layer of ice. Europa, like Enceladus, could have the right conditions for life to form, though we still know much less about its oceans than we do about Enceladus. In many ways, Enceladus serves as a beacon in the search for life. Its proximity to Earth and the wealth of information gathered by Cassini have made it one of the top candidates for future exploration. Missions to study Enceladus more closely are already in the planning stages. The next step might involve sending a probe that could enter Enceladus plumes, sampling the water and chemicals, and perhaps even looking for signs of life itself. The discovery of life on Enceladus would not only transform our understanding of the cosmos, but would also underscore the resilience and adaptability of life. It would suggest that life can thrive in places we never thought possible, not just on a rocky planet with a temperate climate, but in the depths of icy moons, far from the warmth of stars. What makes Enceladus so extraordinary is not just its hidden ocean, nor its geysers erupting into space. What makes it extraordinary is the door it opens to new possibilities. If life is thriving on Enceladus, it would rewrite the story of life in the universe. Just think about it. A world where life exists, not in the warm, bright environment we associate with life, but beneath the ice, in the dark. Enceladus could teach us that life is not limited to Earth-like planets. Life could arise in places we never expected, on moons, beneath ice, in oceans far away from the sun. And if life exists on Enceladus, how many other hidden worlds, deep within the icy moons of our solar system, might harbor similar secrets? Enceladus is just one small part of our vast universe,